Hello everybody and welcome to this tutorial, and we're going to do some mesh in Houdini. So I'm just going to show what we're going to make in Unity, but we will only be doing everything in Houdini. So this is what we're going to do. So we're going to make sure we have some vertex color on this mesh, and when we've done this one in the next tutorial, we're going to make something like this. But first we need to do this ring. So I'm going to save it in a new folder. So we're going to work from scratch. So this is our scratch scene. And this is an empty Houdini file. And we're going to save it here. And this location is over here. So this is the Houdini file I just showed you. So whenever we save the assets, we're going to have them next to the Houdini file here. So that's really nice. So first off, we're going to make a geometry node and jump in, and we're going to have a circle polygon. So this one has, and here we have 12 points. So, and we can see the points if we do like this. So each point gonna represent a box. So we're actually gonna copy, and we're going to use this copy to points this one, and we're going to have it like this, a box. And yeah, it's too big, so we're going to do 0.05. And if we look like this now, you can see we have a lot of boxes around, so this is nice. And if we do in the direction forward direction, that's going to be Z. Or actually, I think it's gonna be this one. So do here too. Yeah. So now you see we need it to be along the point. So the way we can do this, if we just look at these points, we're gonna do fewer first. So we need to make a matrix and convert that to Euler. No, sorry, not a Euler. Quaternion. And the way to do this, first we need to get the directions. So if we imagine here we have the black line, we need a tangent going along with the curve, and we need an up direction and a right by tangent direction. So for instance, this one up here, this is the blue one is the forward, the red one is the by tangent, and the green one is the normal. So we need to create them, and when we create that matrix, we just convert it to an Euler. Sorry, not Euler, it's a quaternion. I'm saying wrong, quaternion. So if we take this polyframe, and put it here, it can actually calculate some stuff for us. So here it does. Here, no, I'll only have points on this line, but if we tick here, we get the normal. And here you can see the normal is like this. And also the tangent here, we can't see that one, but we can fix this. So if we do n, we can actually have n as n. Or actually we by tangent. And tangent is going to be tan. So if we go into this this thing here and right click, here we can add our own markers. So we're gonna have the first one gonna be tangent, and it's gonna be is it a marker? Yeah, a marker, and then it's a vector. So now you see this tangent is yellow, so it's actually pointing inwards. That I find a little bit strange, because we're actually going to have, is it this one? Yeah, it's a bitangent. So the bitangent is what we're going to have as a tangent. So we are also going to have it to blue. I like blue to represent tangents. So you see now the tangent is going along the curve. And if we do bitangent and we just do a copy here, so now we have a copy, we have a this one, and we do a bitangent, and we're going to do that green. So then we have it here. This should be all red. So, and active, we need to press it active here. Now you see we have the red one. So the last thing we need is to do the normal one. And there is two ways to do it at this moment. So one way you could just do, let's see what this is, if we do normal to this one. Yeah, we could use that one actually. I'm going to show you how to do the cross product. So here in each point we have the tangent and we have the bitangent. So if we do a vector normal, we do a cross product, and then we just use these ones. And we do a vector at bitangent, like this. And cross like this, then we have the normal. And if we do just v at n is equal to normal. Now you see we have the normal upwards, but they don't have the same length. And that's because the normal is a special attribute. So if we do our, if we do normal like this, then create it ourselves. I'm going to explain what's going on. So we can actually open this one and copy, and then we do normal, 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 and normal. We do this to green one. Now you see it's taller. And the reason why it wasn't taller a second ago is because it's scaled down like this. But I want it to be as tall as this one, because then it represents it in the correct way. So now when we have these three vectors, tangent, the blue one, we have red, the bitangent, and green, the normal tangent, we can create a matrix. So if we do p at, or actually, matrix mat is equal to, and if we do set, we kind of create. So what we need to do, we need to have x, y, z, and x in our case is, it's actually bitangent. And I is the normal, so it's going to be at normal. Then z going to be the blue one, so that's going to be our tangent. And you can see x, y, z usually have this red, green, blue colors. So you can actually see that I have the correct colors for the correct matrix stuff. So it's actually kind of the same to be x here, I here, and z. You've probably seen that in the matrix. So now when we have this one, we can just create it as an orient. And orient is the same thing as a quaternion. And if we do a quaternion function like this, then we created an orient like this. And actually the matrix need to be 3 by 3 and not 4 by 4. That's it is now. We just do matrix 3, and now this green squiggly thing will remove. So now you see when we copy here, the reason we now did this is because the points are correct transformed. And we need to, because forward is the I, we need to change it like this. So the reason we do this is because now we can just create so many more here. And then we just do this jitter, point jitter. And actually we're going to do this here. Oh, why isn't this working? What am I thinking about? Oh yeah, well, it do work. We just need to look at the right node, of course. So here you have it. And if we just take the jitter and scale it down, now you see we're starting to get this awesome thing. And if we just take the original circle and do maybe 1000 points, now you see we're starting to get this. Super cool. So the last thing, we could leave it like this. So the jitter, if we just scale it more in some axes, you see we can do some more jitter in a certain angle like this. So that's super nice. And yeah, isn't it cool? So you can tweak it as you like. Actually, I think I'm gonna leave it like this, or I'm gonna show you one thing that you could do if you want to make even more randomness to it. So that would be to add some scale to it, and then for each point you want to do a random. For each point here, you want to do a random p scale. P scale is the size of it. So what you could do, if you do like this, if you do for each point, so this is a for loop, and if we just plug this one in here, just make sure that these ones are correct. So now we didn't really do anything new by this thing, but now we can do something for each point. And if we take this first input and do create meta node, now if I middle click on it, you see we have iteration and num iterations. So what we can do with that is to have a point attribute here. And what's really nice is that now we can, let's see, scale it differently for each point. So the first thing we need to do is to make some variables. So we're going to make a float minimum. It's going to be equal to a minimum. So it's going to be the min size. And we're also going to have another, so this is going to be the max size. So actually, let's do a float seed. This is going to be the seed if we want to change the size. So if we have these ones, so we click here and then we have them. And if you do float random is equal to so random, if we do first, let's do int iteration, iteration. So we're going to pick detail, and we're going to pick detail in this node here. So we will take detail and we pick in the, not the 0 input, but we're going to have number 1 input. We're going to pick iteration. So now we have the, here you can see what point we are working on. So we have 1000 points to work on. So now when we pick iteration, we have from 0 to 999. So when we have this, then we can just do a float random and we do iter. And I'm actually going to multiply with 1.23 because then I think it's convert the int to a float. I guess another thing would be to do float like this. Like that. And then I'm going to do plus seed. So now we have a random number. Actually, I'm not sure that works. I'm going to remove it. I haven't tried it before. So, but now we have a random number. And now we just need to do the size. So it's going to be float p scale is equal to, and then we're going to use this fit node. And then it wants the value we're going to rescale. So it's going to be the random number, and that's going to be between 0 and 1, because this one always return between 0 to 1. So we have the value. It's going to be inputs between 0 and 1, and we're going to remap it between min and max. So now this point has a p-scale. So here you see the p-scale value is almost 0.58. Now you see all the points are different sizes. So if we just work with this, you can see we can have different sizes. And I like that because that kind of breaks up this shape a little bit more. And I'm going to do 1500 points, and I'm also going to do this scale 2 times. And this now, because of this, we have the same size. Wow, this looks huge actually. It doesn't now. Okay, so if I'm looking at our reference or our goal, so they look so much bigger, but I think I'm just gonna in this one, because here we have set size. So I'm just gonna do this max size until 3. Okay, so this is better. Now we see it's really big. Then we have a really small one too. And also I'm going to do this jitter and scale it even more. And some more here. A little bit less. Yeah, I'm going to leave it. This is going to be so good. So now when we have this mesh, it's kind of not so optimized. There's a lot of boxes in here, you know. So I'm going to do a really nice node that's called VDB from polygons. So now we're going to make a solid mesh. So here I'm going to crank up the resolution. And now you see, so inside here, it's kind of nothing. And if we do a VDB convert, we can convert it back to a mesh. So we're going to have polygons. So you see now it's kind of super dense. And here we have a lot of mesh. But now, okay, so I'm actually going to do this even more quality. It's going to be super heavy. Depending on your machine, you can do this, of course. I'm going to do even more resolution. And then we're going to convert it. And now, in the adaptivity in this convert VDB node, if you just drag it a little bit, you optimize it a bit, and then you can do a poly reduce again and just remove even more. So now this is actually polygons 250,000. It's pretty a lot, but I think I'm going to leave it for 130,000 polygons. It's going to be fine. So you could, of course, optimize this, but I'm going to leave it for this. And now, a really nice node. We're going to do this measure curvature, labs measure curvature. So if you don't have it, you need to install this labs. Where is it? side effects lab. So you need to install or update, then you find this one. So, and now here you see we're starting to get some color, and maybe you're happy with this. So we can use the green. So the convex is the red part. We can remove that, or yeah, or we just do value on the concavity. Then we just do an so let's see. So you can see here CD is the color red and green. So it's already set it up for colors for us, so that's good. So the last thing we're going to do is have an labs out the UV node to UV map it for us. I'm gonna let it work a bit. Here you can see packing it working. So not done in here. So now we have it UV matte here. Thank you, Houdini. And the last thing we're gonna do is to do transform, because between Unity and Houdini, it's a scale difference. So 100 like this, and then we have it correct scale. And then we do a ROP FBX, and this is gonna be the A stone ring. Then save it. And now we're gonna try it out or check it out. So we're just gonna make a shader, and we're gonna make check vertex color, and yeah, actually we can just do like this, create material, and this is gonna be a universal. This should work. It definitely should. So it's gonna be, isn't it something like this? I don't know. It should be some simple vertex color here. I'm not gonna unlit maybe. Color. Let's try color. No. Okay, we're gonna make one ourselves. So we're gonna make it material and put it on, and in the shader we're just gonna add vertex color like this. Save it, and in the scene we see the colors. Super nice. So now, of course, if you're not really happy with the masking the color, because the green gonna represent the glowing later, then you can just go inside to this node here, and then you can just, in the concavity, you can just rescale it like this. So maybe this is better. We want a little bit more glowing part, but you know that better when you do the shader. But I'm gonna save it like this and be happy with this result. So this is the mesh we're gonna have in the next tutorial. I'm gonna let it pack and finish here. And save it. And now you see it's more perfect. So I'm gonna leave it like this, and if you want to see the really cool shader in the next tutorial, I'm gonna make this one here. So thank you so much for watching, and see you in the next tutorial.